Okay, we're going to be doing mass to mole conversions. This is where we can convert the units from mass in grams to moles, or vice versa. We can also convert to the number of atoms. There's a specific system that works in solving these problems. We start by identifying our given information. In this question, it asks, how many grams are in 3.5 moles of helium? The given information is 3.5 mole, so that's where we begin. The next step is to take the unit of mole and put it catty-corner in the bracket so that we can anticipate that those will cancel each other out. The grand scheme is that we can convert from moles to grams or grams to moles. So grams, our desired unit, goes up above. Now we have to figure out how many grams for how many moles. It will always be 1 mole in these conversion factors. We use the periodic table to find how many grams helium are. Helium is 4.00 grams. When you multiply 3.5 times 4 divided by 1 in the bottom, the answer you get is 14. So the answer is that in 3.5 moles of helium, there are 14 grams of helium. This system also works if we need to go from moles to atoms. But in this case, we will use Avogadro's number of 6.022 times 10 to the 23rd atoms for every mole. The question asks, how many atoms in 3.5 moles of helium? Step 1. Begin with the given, 3.5 mole of helium. For every 1 mole of helium, we put mole in the bottom so that they will cancel out. There are how many atoms? Correct. Avogadro's number, 6.022 times 10 to the 23rd atoms in each mole of a substance. The answer is 2.1 times 10 to the 24 atoms of helium. Now this makes sense. It takes a lot of atoms to add up to a mole. We have more than 1 mole. We have 3.5 moles. So the number ought to be about triple, and in this case it is. This process works for more than just atoms. It works for molecules. If we begin with a quantity in grams, for example, 7.2 grams of water, we can take the molar mass of water, which adds up to be 18.02 grams, and that would be the mass of 1 mole of water. In this situation, grams and grams cross-cancel. We're left with the unit of moles. All we have to do now is the math in the calculator. To 2 significant digits, this works out to be 0.40 moles of water. Let's apply this system one more time. In this case, we're going to start with 1.9 times 10 to the 26 atoms of boron. Now, we don't have a conversion factor that will take us from atoms to grams, so we have to take it to the mole. We put atoms in the bottom and mole in the top. That way atoms and atoms can cancel and we'll convert it to moles. All these conversion factors are based on 1 mole of a substance. And yes, this is where Avogadro's number comes in, 6.022 times 10 to the 23rd. That's the number of atoms of boron in 1 mole of boron. The final step is to state how many grams of boron there are in each mole. The atomic mass of boron from the periodic table is 10.81 grams. Now that moles and moles cancel out, our final answer will be stated in grams. We just need to plug this into the calculator. And the resulting answer is 3.4 times 10 to the 3 grams. Truly, when in doubt what to do with these calculations, take it to the mole. If it's already in moles, you only have two options: convert it to grams, or go the other way, convert it to atoms. Go back and practice some of your other problems now that you've watched this, and see if you can get the right answers. See you in class.